Hi 8th grade, this is Ms. B here with lesson 5.4, and today we're going to calculate the volume of three-dimensional solids, specifically focusing on cylinders, spheres, and cones, whereas yesterday we studied triangular and rectangular prisms. The volume of a three-dimensional figure is the amount of space that it occupies. So we're literally solving for how many how many cubic units, how many little cubes we can fit inside of a given shape. So let's start by answering the questions listed below. How many 1 meter cubes will fit in a single layer at the bottom of the cylinder? So if we have this cylinder and it has a circle with a radius of 3 as both bases, to find the area of that circle, we're going to multiply pi by the radius squared. So the area would be equal to pi times 3 squared. So we're going to go on ahead and substitute this entire expression into our calculator. And we're going to round to the nearest hundredth. So we have 28 point. Actually, I'm sorry, your handout should say to round to the nearest thousandth, so we're going to round 3 decimal places. 28.274 meters squared. So that's the space that would occupy the bottom of our cylinder. How many identical layers can be stacked in the cylinder? How can we determine this? So if you notice the height, which is 6 meters, this tells us that it's going to take 6 of the same type of circle until we reach the very top, the second base. So it's going to take 6 layers, since that's our height, to reach the top of our cylinder. In order to determine the total number of cubes that can be packed into the cylinder, well, if our first layer has 28.274 meters squared, that first circle as our base, and we can stack 6 of these one on top of the other until we reach the top, we're going to multiply it together. So we have our area of the circle times the height, which is equal to 163.6 meters cubed. So for number 3, it should say to round to the nearest tenth. We're rounding 1 decimal place. So we can fit approximately 163.6 cubes inside of this cylindrical container. So the volume V of a cylinder is the product of the, what did we find here? We found the area of the circle. So it's the area of our base and the height of the cylinder. So that's how many different layers of our base we can stack one on top of the other to reach the top. So the formula for the volume of a cylinder is found by finding the area of the circle, which is pi r squared, and multiplying that by the height. Here's the formula sheet that we'll be referencing for the remainder of this unit. So we have the area of all the different two-dimensional shapes that we've studied so far: triangles, parallelograms, and circles. Don't confuse the area of a circle with the circumference. The circumference is kind of like the perimeter of the circle. It's just the outside measure. And then we have our prisms. So the general prisms would be a cylinder, a triangular prism, and a rectangular prism, where, well, actually not a cylinder, even though they're similar, where we're finding the area of the shape of our base and multiplying it by the height. And then these are the 3 that we'll focus on today: the cylinder, the sphere, and the cone. So let's take a look at the next example, and we'll work this one out together before you practice independently. The Darlington Water Company is planning to build a new water tank to improve the quality of their water. They're considering 4 different designs: a cubic container, a cylindrical container, a conic container, and a spherical container. The side length of the cube is 200 feet. The cylinder has a height of 200 feet and a diameter of 200 feet. The cone has a height of 200 feet and is 200 feet in diameter. The sphere has a diameter of 200 feet. Label the given information on the figures below, then answer the questions that follow. So pause this video, try to fill the dimensions of each of the 4 shapes that were given based on either the diameter, the height, or the width, and unpause it for the solutions. So for a cube, since we know all sides of a cube are the same, the length, the width, and the height would all be 200 feet. In our cylindrical container, we have a diameter, so the circle that's at the top and the bottom would be 200 feet all the way across from one end to the other end, going through the center. And the height of the container is 200 feet. The cone also has a circle with a diameter of 200 feet, and the height of the cone from the base to the very bottom is 200 feet. And finally, our sphere going through the center, so imagine it's going through the core of the sphere. So imagine a ball in your head, or a planet. Think of planet Earth. So going through the very center, we have a diameter of 200 feet. So now our job is to figure out which of these containers will hold the largest amount of water. And in order to do that, we have to figure out the volume. We have to figure out how much space it can hold inside. So take a moment to determine which of these containers you expect to have the highest capacity. So which one of these do you think is going to hold the largest amount of water? And we're going to go on ahead and share that out. So pause the video. So let's find the volume of each tank and show our work in an organized and coherent manner. So what we're going to do is actually write out, and you know what I want you guys to do, and it's very difficult for me to do this on the iPad, I want you to go on ahead and also label each of the dimensions on the next page as well, so that we can reference it while we use our formulas. So mine is going to look a little bit messy, but it would be easier for you since you're using a pen or a pencil. So I'm going to write down the formula so that I can keep my work nice and organized. The formula for the volume of a rectangular or cubic prism is length times width times height. So in this case, since the length, the width, and the height are all the same, we're really doing 200 to the third power, 200 cubed. So the volume of this cubic container is going to be 8 million feet cubed. That means if we take 8 million 1 foot by 1 foot by 1 foot cubes, that would fill up this entire container. So let's go on ahead and find the volume of the cylindrical container. So the formula for the volume of a cylinder is pi times the radius squared, so we're multiplying the circle that's on the base, times the height of that shape of our cylinder. So in order to calculate this, we need the radius and we need the height. So the radius of our cylinder, if the diameter is 100, our diameter is 200, our radius, or half of that, would be 100 feet. And we're given a height of 200 feet. If I'm doing my best to label this for you, you guys better be labeling it on your papers as well. So I'm going to go on ahead and substitute 100 for our radius, and the height of our cylinder is 200. So now we're going to go on ahead and substitute pi times 100 squared times 200 into our calculator. If you can't find the squared button on your calculator, you can put 100 times 100 first and then multiply it by pi and then multiply by 200. So the total volume, rounded to the nearest hundredth, of this cylindrical tank is going to be 6,283,185.31 feet cubed. So far we can see that the the cubic tank holds more water. So let's do our last two. We have a cone with a diameter of 200, which means the radius will also be 100 feet. And it has a height of 200 feet. So the formula for a cone, if you look at your reference sheet, the volume is equal to 1/3 of pi times the radius squared multiplied by the height. So volume is equal to 1/3, now I'm substituting my radius and my height, times 100 squared times 200. So again, go on ahead and substitute this entire expression into the calculator. So we have 1/3 times pi times 100 with the square button times 200. Or what we could do is substitute everything from pi to 200 and then finally divide our answer by 3, because multiplying by 1/3 is the same as dividing by 3. So that's going to give us a volume, rounded to the nearest hundredth, of 2,094,395.10 feet cubed. Okay, and finally we have our sphere. And our sphere, the volume is found by multiplying 4/3, oops, that's not a 3, 4/3 times pi times the radius cubed. So since the diameter of the sphere is, again, 200, that gives us a radius of 100. So we have pi times 100 cubed. And we're going to go on ahead and substitute this into our calculator. Or what we could do is, let me block it off with a red. You could do 4 times pi times 100 to the 3rd power, and then divide your answer by 3. And that's going to give us a volume of 4,188,790.20 feet cubed. So now that we've calculated the volume for each Ford type of tank, we see that the rectangular, I keep saying rectangular, I mean a square is a rectangle, so a cube is still a rectangular prism. So we still see that the cube holds the largest amount of water. The one that would hold the least amount of water would be the cone. So keeping those numbers in mind, we're going to answer the next two questions, and this is very, very important in comparing the formulas for the cone, the sphere, and the cylinder. So number 3 says, how does the volume of the cone compare to that of the cylinder? Well, the volume of our cone was 2,094,395.10, and the volume of our cylinder was 6,000,000, let's write this out first, 395.10 feet cubed. And so this is the cone. The cylinder, I'm going to write CY for my cylinder, was 6,283,185.31 feet cubed. So if we're just looking at these values, we can see that the cylinder is actually 1/3 the volume of, I'm sorry, I'm saying that wrong. The volume of the cone, I'm confusing myself because I wrote C and CY. So the volume of our cone is 1/3 the volume of our cylinder. So if you take a look at the formula for a cylinder and a cone, all we're really doing is multiplying the cone by 1/3, which is why its volume is also a third. In this case, if you substitute I'm sorry guys, I'm saying this all wrong. If we multiply